Now, let's set our Universe app to random and tap the button. What are the chances that the app will luck onto a gravity setting that just happens to allow life to emerge? Scientists have crunched the numbers, and the answer? Not good.
You mean not good like 1 out of 100?
I'd say 1 out of 1,000,000.
Actually, for gravity, it's worse. Worse than 1 chance in 1,000,000,000 times 1,000,000,000,000 times 1,000,000,000,000.
So you're telling me there's a chance?
Yeah! Yeah! We all love rooting for long shots, but here's the thing. It's not just gravity. There are many other physical laws that also have to be just so for life to emerge in the universe. And some of them are even more fine-tuned, even more unlikely than gravity.
The problem is, to write the fine-tunings off as merely coincidences seems far-fetched.
Look, if I see my kid eating a chocolate chip cookie and my kid said, oh, the cookie jar fell over and the cookie fell into my hand, will I believe that, or do I believe he stuck his hand in and grabbed the cookie? I believe the latter because the former explanation is so fine-tuned. The cookie jar would have to fall over at the right moment. His hand would have to be there just to catch it. That just seems unbelievable.
The best example in my mind is the cosmological constant, the energy density of empty space, the vacuum energy. This is something that we think is not zero. When I was your age, we thought this was zero when I was in graduate school. But in 1998, we found that the universe is accelerating in a way that is exactly compatible with a small but non-zero energy density in empty space. Now, the reason why that's interesting is because you can sit down and ask yourself, if I didn't look at the universe, if I just estimated on the basis of what I know about particle physics and cosmology, what would I guess the value of the vacuum energy should be? My guess is larger than the observed value by a factor of 10 to the 120. That is to say, if it is true that we have a non-zero but small vacuum energy, we did not pick it randomly out of a hat. We think we know what the natural value would be if we did pick it randomly out of a hat. It is very, very, very different than the value we actually observe. So either our notion of picking randomly out of a hat is very, very wrong, or there is some dynamical explanation for why the value for the vacuum energy is so small.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything is bad. And a physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120, 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, 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 trillion. Otherwise the universe would be so drastically different that it would be impossible for us to evolve. That the cosmological constant arrived at such a tiny value by chance seemed to be out of the question.
I don't find it quite plausible, or at least, as a working scientist, it sounds like a cop-out to me to say, well, we just got lucky, the laws of physics allow for us to be here, isn't that nice, let's move on. I suspect that this apparent fine-tuning of the vacuum energy and other constants of nature are clues. They're telling us something. There's something we don't understand about the universe. We should try to do better. So I'm going to put aside this possibility.
What's crazy is to think a thing is a fluke if it's 123 decimal places.
That tiny value of the dark energy is a fine-tuning that demands explanation.